Hi! We are doing problems based on Pythagoras theorem. I am sure you remember the concept of Pythagoras theorem. Alright. So, here's a question for you. ABC is a right triangle, right angled at vertex B. Let D and E be any points on AB and this should be BC. Alright. AB and BC respectively. Prove that AE square plus CD square is equal to AC square plus DE square. Alright, this is DE. So somewhere the other small right angle triangle DB is also into picture. See children, there is one right angle triangle ABE. There is one more right angle triangle ABC. There is one more right angle triangle DBC also, right? And there is one more right angle triangle DBE. So altogether 1, 2, 3 and 4 right angle triangles are there. Now what am I going to do is I'll say we know that angle B is equal to 90 degrees. Alright. So if angle B is equal to 90 degrees in triangle DBE, what is DE? DE is hypotenuse. So I will write DE square is equal to BD square plus BE square. Alright, BD square plus BE square. Alright, and I will call this as equation number 1. I am going to use this in the future. Now let me consider a triangle ABE. I'll say in triangle ABE, in triangle ABE is hypotenuse. So I will write AE square is equal to AB square plus BE square. AB square plus BE square. I call this as equation number 2. Now I will consider triangle DBC. In triangle DBC. See, in every case B is involved and which is 90 degrees. Now I will take CD square, which is hypotenuse. In triangle DBC, CD square is hypotenuse. The square and the hypotenuse is equal to sum of the squares of other two sides. So it is BD square. CD square is equal to BD square plus BC square. BD square plus BC square. Alright. Now there is something else which we are forgetting. We have taken this triangle. We have taken this triangle. Now I will call this as equation 3. Alright. Now what I am going to do, I have to get AE square plus CD square. AE square plus CD square. So I will say consider 2 plus 3. So when I consider 2 plus 3, you will get AE square plus CD square is equal to, let us add the things. I have AB square plus BE square plus BD square plus BC square. Now from equation 1, BD and B, can you locate? Yes, you can locate BD and B. Alright. So I will write from 1 BD square plus BE square is equal to, what do you have? DE square. So what will I write? Therefore, AE square plus CD square is equal to, what do you get this? This is DE square plus leftover is what? AB square plus BC square. AB square plus BC square. Now that also I have to handle. Where is AB? This is AB. Where is BC? This is BC. Now in triangle ABC, already we know. Also in triangle ABC, AB square plus BC square. AB square plus BC square is equal to AC square. Why? Reason is angle B is 90 degrees. Is it not? So in the next step, what is AB square plus BC square? I am going to replace as AC square. Therefore, AE square plus CD square is equal to DE square plus, what is AB square plus BC square is equal to AC square. So have a look, is that what you are supposed to show? Let me read. AE square plus CD square is equal to AC square plus DE square. Is it not simple? So there are 4 right angle triangles used here. 3 I have used first and the 4th one I have used it here. Alright, so please have a look and try to do it again and again. Meanwhile, I will pause the video and we'll go for the next question. Yeah. Children, a very important question. Many times this question has come in the board exam. So please focus and listen. prove that sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonal. Now like this he will give you, and he won't give you figure, we have to draw figure on our own. So let A, B, C, D, and while writing also A, B, don't write C here, write in a cyclic order, A, B, C, D or A, B, C, D. That is very important. I will just say let A, B, C, D be the rhombus. Let A, B, C, D be the rhombus, and let diagonals intersect. Let diagonals intersect each other at O. And you know children, the best part is diagonals intersect each other at right angles. This is the property of a rhombus. In square and rhombus, the diagonals will always intersect at right angles. Alright. So I am drawing this diagonal. Make sure that you draw, but it is a construction, so you draw a dotted line. Right? This should be dotted line. So also, alright. ABCD is a rhombus. So diagonals intersect each other at O. Now I'll write, we know that in rhombus, what, let me first write required to prove. Okay. Now, what is required to prove? Required to prove is the sum of the squares of sides of the rhombus, means AB square plus BC square plus CD square plus AD square. Required to prove is AB square plus BC square plus CD square plus DA square. Sum of the squares of the sides is equal to sum of the squares of a diagonals is equal to BD square plus, sum means plus, BD square plus AC square is equal to BD square plus AC square. Right? This is your required to prove. Now what am I going to do, children? See here. Since ABCD is a rhombus, we know that all sides are equal in rhombus. AB is equal to BC is equal to CD is equal to DA. All sides are equal, and diagonals bisect each other at right angles. This is a very, very important property. Bisect each other. What do you mean by bisect each other? This diagonal will divide this into equal parts. Two parts is something different than two equal parts. Make attention over there. And this diagonal will divide this diagonal into equal parts. So I need to write that. What do you mean by that? I will write OB is equal to OD, and that is equal to BD by 2. Alright. And similarly, OC is equal to OA, and OC is equal to OA, and that is equal to AC by 2. So these two things are of help to me. Alright, sir. Now I also mentioned to you that they bisect each other at right angles. Means what is the angle over here? 90 degrees. So I'll say in triangle BOC, angle BOC is equal to 90 degrees, because diagonals bisect each other at right angles. So when BOC is equal to 90 degrees, what can I write? I will write BC square is equal to OB square plus OC square. Alright, BC square is equal to OB square plus OC square. Now what am I going to do? I will write BC square is equal to, what is OB? OB can be replaced as BD by 2. I will make a replacement, BD by 2 whole square. Now what is OC? OC can be written as AC by 2. I will write this as AC by 2 whole square. What am I going to get? I will get BC square is equal to BD square by 4 and AC square by 4. Now when I take the LCM, BC square is equal to BD square plus AC square by 4. Now when I cross multiply, I am going to get 4 times BC square is equal to AC square plus BD square. Now children, 4 times BC square. Let us write 4 times BC square. BC square plus BC square plus BC square plus BC square is equal to AC square plus BD square. Now why am I writing 4 times? Now you see, I have already written what is BC is equal to AB. So here instead of BC square, I will write AB square. and this BC square I'll leave it here only, BC square. This BC I'm going to change. What is BC is equal to CD. So instead of this BC square I'll write CD square. Again BC is equal to what? DA. Again instead of this BC square I'll write what? DA square is equal to what will you get? AC square plus BD square. So please try to understand, the entire trick is here only. This part and this part. I am writing 4BC square, means 4 times BC square. Every time using these relationships, all sides are equal. Only one BC I'll keep fixed. Remaining BC I'll replace with AB, CD and DA, and therefore what you get is sum of the squares of the sides of a rhombus is equal to sum of the squares of their diagonals. Very, very important problem. I want you to practice umpteen number of times. Alright children. So thank you, take care and keep practicing, and more importantly keep liking the videos, but like it only once. If you hit it 2 times it will go. You have to like only once and keep sharing as well. Thank you, bye bye and take care.